Okay, so this is going to be a basic review of graphing lines, as well as a few things for geometry. So uh, let's see. Well, actually, I think these notes, never mind. These notes are basically all about graphing lines. So if you don't remember what a line is anything with a x or y variable, x and y variable as well. And they are only raised to the power of 1. Yep, this is all about graphing lines. And those are going to be your notes for today. So first of all, let's define what a line is, okay? Just so you know. This is not a line because it has a square, not a line. This is not a line because even though it has x to the 1 and y to the 1, they aren't on the same level. And so this is not a line. This is not a line. Because even though they are to the same level, they're multiplying. This is a line. This is a line. Okay? This is not a line. This is not a line. Okay? Get the idea. The idea is that you just have some value of x or y and y, okay, but to the power of 1. That's a line. Okay? So you should know y is equal to mx plus b by now. This is actually an easier form. Okay, this is y equals mx. It's not that the b doesn't exist. You just need to remember that the b is 0. Okay, and you actually don't even need to remember it. Here's what I want to give you guys. I want to give you the power to know that you can graph anything at any time. I don't care. You could graph any single one of these things right here if all you do is make a table. It doesn't matter. You can graph anything if you can make a table. And this is an input-output table. So I'm going to show you a couple ways to do it. Usually we put x and y, okay? And then you do at least 3 values, and you want to pick a negative value, 0, and a positive value if you can, okay? If it makes sense, and we'll talk about that in a second too. What just happened to my tablet? What happened to my tablet? Why is it okay, there it goes. I don't know what happened to it. So typically what this means is that you're going to be plugging in x. And kids always wonder, what the heck? What x do I put in? Any x. It doesn't matter. Okay? There are better ones to choose sometimes that are like make it easier for you, but honestly, there really is no limit. You have an infinite number of choices. But what do you want to pick? You want to pick something you can actually graph. So you don't want to pick 100 because that's way over here. So that wouldn't make any sense. You want to pick it around the origin just because that's how these are given and that they make more sense. Okay, we always want to have this. Now you have the advantage because you have Alex, and Alex will make it easier for you to graph. Okay, so all you're going to do, pick 3 values. I'm going to pick -1, 0, and 1. Those are some of my favorite numbers to pick because they're super easy. So if I plug in a -1, that means I go 4 times -1. It says y is equal to 4 times x. See, I'm just plugging in x, and I get -4. And then this is y equals 4 times 0. That equals 0. This one is y is equal to 4 times 1, which is 4. See, with an input-output table, what you're given is the x goes in, the y gets spit out. These are points, -1, -4, -1, -4. 0, 0 is the next point. See, they're just points. 1, 4. So 0, 0 is a point and 1, 4 is a point, and then you connect them. Now I can't connect mine like you guys can. Mine are, it's going to be ugly because I'm on my tablet. It's really hard to connect. Okay, but you guys will have an easier time because I believe it just makes you graph a couple points and then you can connect them. Okay. All right, so we're going to move on to the next one. I'm going to be graphing so many of these, you're going to get very used to the table. I'm going to show you a different table this time. Okay, I don't know if you have done this before. It's an input-output table. Okay, but instead of putting the output like this, you put the equation here. and then you put y. This is just a different way. Oops, I don't like that. It's just a different way to express it. That's all. Okay, it's basically putting the equation in the middle of the table. I don't do it this way, but I have seen a lot of kids that like it, so I decided I would try to show it. Okay, sorry about the crooked lines. Okay, so here's a 4/3. In this case, it's still the same. Notice B is still 0. Okay, but notice this is a fraction, 4/3. Okay, here's a tip. This is a nice tip. Pick X values, hello, values that are multiples of the denominator. Okay, if you have a fraction, I should say if fraction. Okay, it makes it easier. Let me show you. Okay, I'm changing colors because why not? Okay, I'm going to plug in multiples of 3. And the reason why we're going to do that is because it's going to cancel it out. So I'm going to put -3, 0, and 3. Now, could I have put -1, 0, and 1? Yeah, it would have been fine. I just would have had to graph a fraction. It's not that big of a deal. But it makes it easier in this way. So I'm going to do 4/3 times all of these. Okay, I'm just going to do it in black while I have the black marker open. Here we go. And then we're going to plug it in. Times what? -3. Now, notice I did that. That makes it hard to do. So when you plug it in, instead put the -3 on top like that. That will make it easier. And this one, put 3/1 like that. If you put your fractions and your whole numbers like this, you will not get confused because 4 times -3 is -12. -12 divided by 3 times 1 is 4, -4. Or you guys could cancel. 3 goes into 3 once, and then that leaves 1 on the bottom, so you're done, and that's -4. Anything times 0 is 0. This one, the 3's cancel, or you get 12 divided by 3, and you get 4. Okay, and then you come over to your graph, and hopefully you don't graph it as, feel like I'm in some weird alternate like universe that's crooked. Okay, so we're going to go -3, -4. I really can't do this. It's because this tablet is crooked. I'm so sorry, you guys. Okay, 0, 0, and then 3, 1, 2, 3, 4. It's a crooked world. Okay, so basically you're just going to plot the points. This is impossible. Oh my God, this is so hard. Okay, sorry. You get the idea. I can't do it because I can't do it, but you guys will be able to do it. Okay, on Alex or on graph paper with a pencil. Just don't have a tablet like me. All right. Take a look at this one. It doesn't look like the last one. This one has a b in the form y equals mx plus b. Please remember that the m is the slope and the b is the y-intercept. Right now, I'm not actually going into this. We are going to play enough with this that I'm not going to explain it on these notes. On these notes, I really want to drill in. Okay, I have got to figure out how to put this thing so I don't do this anymore. I'm tired of crooked. Okay, let's try that. Maybe that'll help. Okay, on these notes, I really just want you to start to love the table. There. Table. Okay. Gotta love that table. All right. So we're going to pick values for x. Really can't do this. I'm going to, dang it, anyhow, it has to do something with the way my computer is. The way I'm angled. I don't know what it is, but I'm going to work on it. Dang it. It kills me. I'm going to get better at this. All right. So we're going to pick values for x. It doesn't matter what you pick. I'm going to pick -1, 0, and 1 because those are my personal favorites. Okay. And then we're going to plug them in. Again, you can draw the table so you do the math in the table. I'm just going to do it right here. -1 minus 7. I could do formula substitution, you guys. That's the formula. That's the substitution. 8. Okay, now you plug in a 0. Y equals 0 minus 7. Negative 7. And then you plug in a 1. Y equals 1 minus 7. Negative 6. You should see a pattern. You guys look. The slope here is 1 over 1. Look. The rise, it goes, look at what's happening to my x in my table. It's going up 1. Look what's happening to my y. It's going up 1. So that's 1 over 1, rise over the run, rather, 1 over 1, 1 over 1 is 1. Okay? So then all you need to do is graph those points and connect the dots. I am going to show you something. Let's see. No, so let's see, negative 1, negative 8. I'm going to put it here, 0, negative 7, and 1, negative 6. Okay, so the idea here is that, look, it went up 1 over 1, up 1 over 1. Yes, my drawing is not that great because I don't have an official grid, but you get the idea. A slope of 1 has a 45-degree angle. This is just giving you a little bit of tidbits. If you didn't know that, is equal to 45. It's kind of nice to know. 45 degrees. It's kind of nice to know, you guys. And I will actually expect you to know that, but not at this moment. Okay. All right, take a look. Another line. You can pause the video if you want to try to see if you can do this. Okay, again, a table. This time I'll put the math inside just for kicks. Okay, this is how we do it. We're going to substitute it in. Pick your values, any values. This time I will pick negative 2, 0, and 2. Why? I don't know. I just felt like being different. So here's the important part. When you substitute this in, you see these negative? That's part of the formula. That's not belonging to the negative 2. The negative 2 has its own thing going on. So it's negative, and then we substitute in the x, which is negative 2, minus 2. And then negative of the negative becomes a positive. The opposite of a negative is a positive. It's not magic. It's math. The opposite of a negative is a positive, logically. Okay? Something bad happens to you. The opposite of bad is good. Yeah? So 2 minus 2, 0. Okay, now substitute in the next one. Negative 0 minus 2. Well, negative 0 is going to be nothing. So that's going to be minus 2. Okay, last one, negative. If you want to be safe, put it in parentheses, and that just means negative 2 minus 2 is negative 4. Okay, again, plot your points, and you should be good to go. Negative 2, 0, 0, negative 2, and 2, negative 4. Right here. Okay, so you'll notice, look, slope went up 2 over 2. Up in the positive direction 2, negative direction 2. Look, what is the rise over the run? Negative 1. Check it out. Negative 1. It's right here. Negative 1. That's how you get the slope. Up 2 over 2. There's actually a point in here that if you went up 1 over 1, you'd hit it as well. Okay. All right, and connect the dots and you'll have a line. Hey, it's a little better that time. All right. Again, you can try to do this on your own if you want to. Table. The trick, again, with these is to plug in multiples of the denominator. So it's 1/3 x minus 6, and here's y. Okay, so negative 3, 0, and 3. So let's do 1/3 minus 6, 1/3 minus 6, 1/3 minus 6. I'm just doing all the original in blue, and then I'll do this part in green. So we're going to plug in negative 3 over 1, negative 3 over 1. I mean, negative 0. Oh my God. Hello. Wait. There. I erased history right there. Okay, and then this one is 3 over 1. Put them like that and you'll understand. This becomes -3 over 3, which is -1. -1 minus 6 is -7. This becomes nothing, becomes -6. These cancel out, you get 1. 1 minus 6 is -5. Look at the pattern. We went up, on the x, we went up 3. On the y, we're going up 1. What is my rise over my run? 1 over 3, 1/3. That is the slope in the formula, and that is the slope in the table. And then you can see the slope in the graph. Notice 1/3 is less than 1. The slope of 1 has a 45-degree angle. The slope of 1/3 means you're going to go up 1 over 3, okay? But let's try this. It's -3, -7. See, the points are -3, -7, 0, -6, 3, -5. The habit is to put 3 points. And the reason why you put 3 points is in case you screwed up. Okay, 1, 2, 5, 6 right here. And then 1, 2, 3, -5. So you see how shallow this slope is? That's because it's a 1/3 slope. It goes up 1 over 1, 2, 3. Okay, so it goes up 1 and in the positive direction 3. Up 1 over 3. To get from point to point, you go up 1 over 3. Okay, so no matter what, it's 1/3 positive direction. I'll teach you more about that too if you don't have that intuitively there. All right, now we have another one. If you want to pause it, you can. Okay, whoa. Let's try that again. Okay, I'm going to keep doing these tables. They're kind of fun. I've never done them, and I'm kind of enjoying them. 3 values, but we're going to pick multiples of 2 this time. So I'm going to pick -2, +0, and +2. So I'm going to write -3 halves x plus 2. So -3 halves plus 2, -3 halves plus 2, -3 halves plus 2. All right, we're going to use a different color to substitute in. So times -2 over 1 times 0. You can even put 0 over 1, you guys, if you wanted to. Do you know 0 is over 1? Okay, you don't have to. It's silly, but I thought I would just show that to you. Okay, so -3 times -2 is +6, divided by 2 is 3. 3 plus 2 is 5. If this is too hard for you to do, you can always do it here, okay, on the side, like this. And then just be like, okay, that's +6 over 2 plus 2. 6 divided by 2, 3 plus 2, 5. Like you can still work it out like that, okay? 0 times anything, 0 is the great eliminator, and plus 2 is 2. Then -3 times 2 is -6. -6 divided by 2 is -3. -3 plus 2 is -1. Or you can just cancel that out. 2 goes into 2 once, 2 goes into 2 once. You get -3 plus 2 is -1. Okay. So my points are -2, 5, 0, 2, 2, -1. And again, you're just graphing them. Now tell me about the slope. It's negative. -3 halves. It's greater than 1, and the direction is negative. So let's see what happens. -2, 5, 0, 2, and 2, -1. Okay. Yeah, that's right. I'm sorry, my graph just looks wrong just because of the way I graph. Oh my God. Guys, I'm trying. I promise I am trying. Oh, not even close. Okay, whatever. I tried. It's bad. Okay. Notice a negative slope goes in this direction. Positive. This is positive. This is negative. Okay. Negative 3 halves. Notice 3 halves is equal to 1.5. That's greater than 1. A 1 slope is at 45 degrees. A 1.5 slope is going to be steeper. Okay? Just to build, trying to build a little bit of intuition. You think about it, everything on the computer, everything you do on computer that has to do with graphics actually has math written in it. Okay? And they're equations, typically not linear, but sometimes linear. A lot of times it's way more complex than that, but still. So it says graph the line. It's a graphing a line given in standard form. So far, you've been given what's called y-intercept form, which is this one. Okay? A lot of times we are more comfortable graphing it that way because there's a quick way to do it. I will teach that to you. I wanted to concentrate on tables today. Okay. So you have a couple choices. The first way to do it is to change the equation to slope-intercept form. How would you do that? Ready? So if you have x plus y equals 4, well, look at the slope-intercept form. It's solved for y. That means we need to get y by itself. Well, y isn't by itself. What do we need to get rid of? The x. Okay. What is it doing to the variable? It's adding, because it's positive. So we subtract x from both sides. I think jump it over and change the signs. So we subtract x from both sides and we get negative x plus 4. Now you can make a table. And I'm not going to do it again because I think you guys can do it. And graph. The other way to do it is to make a table and find solutions. Okay? So in other words, name two numbers that add up to 4. 1 and 3. 3 and 1. That's what it says, x and y, 2 and 2. All of these are solutions to that equation. So you could just do that. Okay, you can graph it here and then make a table and pick some values for x and y, like -1, 0, and 1. Or you could just find solutions and graph them. They both work. This is the second method. Okay, find solutions kind of by guess and check, by using your brain. Your brain. How do you like that? What a funny way to say it. Okay. Next, let's try the next one. Okay. Again, this one is not given to you in a slope intercept. This is called standard form. I'm going to give you a little more information about that. This is standard form. AX plus BY equals C. This confuses kids a lot. But look, if I write this 2x plus 3y equals 10. Okay, all we're saying is that A represents the number that comes before 2, B represents the number that comes before y, and C just represents the number there. Okay, that's just what that means. That's all. In y equals mx plus b form, okay, example, y equals 2x plus 3. In this case, the m is the 2 and the b is the 3. Okay? These letters just represent numbers. They're not variables. The variables are x and y. Notice x and y stay in both cases. All right, back to this. First method, change to y-intercept form. Y is not alone. Okay, to change it to y-intercept, you solve for y. Okay, y is not alone, so we need to move the x over. It's positive, so let's change the sign. We subtract x from both sides, and this is what we get. Okay, but we don't want negative y, we want positive y. So we're going to use the trick of multiplying both sides by -1. Basically, you're changing the signs of everything. Watch what happens. Negative times negative becomes a positive. Distribute this -1. Negative times a negative. Positive. negative times a positive, negative, sorry. By the way, I talk out loud a lot when I do math because I screw up on negatives a lot, and talking out loud and hearing myself say it really helps. I highly recommend it. Okay, so now you've solved it. Make a table and be on your merry little way to graphing. Okay? Or just use your dang brain because you've got a good one and come up with solutions. What are some numbers? What number minus what number equals 2? How about 4 minus 2? 2 minus 0? 6 minus 4? I now have 3 points. I can graph them. These all work. See? 4 minus 2 equals 2. 2 minus 0 equals 2. So this is the second way. Sometimes you can't do this very easily. These ones are super easy, so that's why it makes it really nice. It's good to know this way for the hard ones. Okay, wow, what's different about this one? Okay, I'm going to give you a bunch. This is y is equal to 4. I'm going to give you another one. How about y is equal to negative 2? How about x is equal to 3? And how about x is equal to negative 1? Okay, what do you notice about all of these? They only have one variable. That's okay. They're still lines. They're still lines. And guess what? At the end of the day, if you can't remember which one they are, how to graph them, you can always make a table. I promise you this will save you. Remember, you could do a table, but it doesn't have a place to plug in X, you say. You're like, thought bubble. But there's no X. That means X can be anything, literally anything. It doesn't matter. What it's saying to you is that Y is always 4. 4, 4, 4, 4. Guess what? X can be anything. Negative 2, negative 1, 0, 1. It doesn't matter. What it's telling you is that Y is always 4. So what does this look like in a graph? Y is always 4. Negative 2, 1, 2, 3, 4. 4. Negative 1, 4. 0, 4. Let's pretend that's 4. 1, 4. In other words, you get a horizontal line. This is y is equal to 4. Okay, what it means is that the distance from the x-axis is always 4. No matter where I go, y is always 4. Okay, so don't count the bubbles here because they don't equal 4. Okay, so it's just thinking it through. Okay, 1, 2, 3, 4. Okay, it's always going to be 4. So this is counterintuitive. The y-axis goes up and down. This is the y. So whenever we see y equals 4, most of us want to draw a vertical line. It's not true. It's the opposite. I can't tell you how to remember it because I have a hard time remembering it myself like I used to when I was a kid. So this was my saving grace. You can always do a table. Look, it doesn't matter what x is. Y is always negative 2. So 0, 1, 2. Okay, that means y is always negative 2. 0, negative 2. 1, negative 2. 2, negative 2. Negative 1, negative, right? It doesn't matter. It's always at negative 2. Horizontal line at negative 2. X equals 3. Okay, again, use a chart. Check it out. What it's telling you is that X is always 3. 3, 3, 3. I could go to infinity, and it would just be 3, 3, 3, right? What's y? Who cares? It can be anything. Negative 2, negative 1, 0, 5, 6, 100. It doesn't matter because x is always 3. So when you graph this one, what happens? We go 3, negative 2. Oops, that's 2. 3, negative 2. 3, negative 1. 3, 0. 3, 1. 3, 2. 3, 5. 3, 100 is way up there. Who knows? 3, negative 4. Negative, get it? It's a vertical line. I'll actually pick a different color because I'm bored too. Okay, here, I keep doing that. Oh God, I'm so sorry. I try. I promise I try. Okay, so you get this vertical line for x equals 3, right at 3. Okay, how about x equals -1? Again, use a chart. X and y. What do we care? X is -1 every time. Y, 0, 0, 1, 2, 3. Okay, so here we are. Graphing this sucker. Here we go. Pick a different color. Okay, graph it. -1, 0. -1, 1. -1, 2. -1, -1. -1, -2. -1, whatever. X is always equal to -1, which means you do that. You connect it, and it is a vertical line. So when you have one variable, it's either going to be horizontal or vertical. I don't remember how, I honestly don't have a trick to remember it. The best I can do is that we say drop your X, as in your ex-girlfriend or whatever, and then think like drop the mic, drop who, and that's a, no, like that. That's a vertical line. I'm sorry, that's as good as it gets. That's all I have for you. Just to use a table, maybe. All right, and that's it.